Hello and welcome back to Chemistry, It Is All That Matters, and today we are going to continue our work through the gas laws, and we're going to look at Dalton's law, which is known as the law of partial pressures. And Dalton's law is a pretty simple law, and basically we're looking at the law of pressures of gases in a fixed or closed system. And basically, it's kind of a no-brainer that if you have a closed system that's at a certain pressure, that the gases inside that closed system cannot exceed that pressure. And so what we're looking at is the total pressure of the system is going to be equal to the partial pressure of each of the gases, and we represent that by P1, P2, P3, depending on how many gases are enclosed in the system. And then N is the number of moles of each gas because it is the ratio of the moles of those gases that affects how much of that gas is present in the closed system. So basically it's the number of moles times the pressure of the first gas plus the number of moles times the pressure of the second gas plus the number of moles times the pressure of the third gas, and so on, equals the total pressure of the system. So let's work through a sample problem for Dalton. And what we're looking at here is we have a closed system and the chamber is pressurized to 1200 torr. If the chamber holds 3 moles of nitrogen, 2 moles of oxygen, and 1 mole of fluorine, what is the pressure of each of the gases inside that chamber? So as we said before, Dalton's law is based on the equation NP1 plus NP2 plus NP3 equals pressure total in the system. And so when we plug in those values, we look at 2P1, 2 moles of oxygen, plus 3P2, 3 moles of nitrogen, plus 1P3, 1 mole of fluorine, equals the total pressure in the chamber, which is 1200 torr. So this gives us a value of 6P, 6 moles times the total pressure, equals the total pressure in the system, and then algebraically we solve for P at 200 torr. Now that is not the final answer, because what the question is asking is what is the pressure of each gas? So now we say that we have 2 moles of oxygen at 200 torr, 3 moles of nitrogen at 200 torr, and 1 mole of fluorine at 200 torr, which gives us our final values of 400 torr is the pressure of the oxygen in this system, 600 torr is the pressure of the nitrogen in this system, and 200 torr is the pressure of the fluorine in this system. So Dalton's law basically lets us figure out the value of each of the pressures of each of the gases in a closed system of gases and how they relate to the total pressure of that chamber or that closed system. Now here's another example of how Dalton's law will work, and here we have a sample of oxygen gas is captured over water at 20 degrees Celsius, and we want to know what is the pressure of the oxygen in the system if the system is at standard pressure. Now we know standard pressure is 760 torr, so we know P total is 760. However, when we look at this system, it's not just the oxygen as a gas in that container. We know that water provides vapor pressure at its surface. So therefore, at the surface of the water there is also water vapor pressure, or water in its gaseous state at the surface. So we actually have 2 gases captured in this container, the gas oxygen and the gas created by the water vapor. So what we have to do is we have to take the temperature of the system, which is 20 degrees Celsius, and we have a chart that we can look up vapor pressure of water at various temperatures. And so at 20 degrees Celsius, the pressure of water vapor is 17.535 torr, which is also 17.535 millimeters of mercury, and you could convert that to atmospheres or kilopascals depending on what your needs are. But this is the vapor pressure of the water in that system. So when we go back to this, that is where we get this 17.5 value. Since the total system is at standard pressure, 760, that 760 minus the 17.5 torr gives us the pressure of the oxygen, which is 742.5 torr. So we have to realize that when we have a closed container system over water, we have to also compensate for the water vapor pressure at the surface of the water. So let's look at one of those sample problems. So here we have a sample of air. It's captured over water at 29.0 degrees Celsius. The atmospheric pressure is at 1.03 atmospheres. So what is the pressure of the air above the water? So what we do first is we're going to first convert our atmospheres to millimeters of mercury, which would be the same as calculating it to torr. And we do 1.03 atmospheres times 760 millimeters of mercury, cancel out the atmospheres and get 782.8 millimeters of mercury. Then once again, we know at 29 degrees Celsius we can look up the water vapor pressure on our water vapor pressure chart, and we see that at 29 degrees Celsius we have a torr value of 30.043, which is also 30.043 millimeters of mercury. So we converted to millimeters of mercury. We have looked up our value of the water vapor pressure, which in this case is 30.04 torr, which we convert to 30.04 millimeters of mercury, which is what our calculation unit is. We take that 782.8 minus 30.04 and we get a value of 752.76 millimeters of mercury. And because the original value was given to us in ATM, we would then convert back to ATM and get a value of 0.99 ATM. So, Dalton's law is the law of partial pressures, and it allows us to find the partial pressure of the gases within a closed system. Remember, this is a closed system. No other gases are being introduced at any time. And this closed system will have a total pressure based on the pressures of the gases inside that chamber. And remember, that can be done based on the mole ratio, and the mole ratio will determine the number of moles in each of the gases in that system, and Dalton's law allows us to calculate the individual gas pressures based upon that. So keep working on your chemistry.